Hello! In this video I am going to demonstrate the basic functionality of Zoe and how it can be used to create a Jupyter notebook and a Spark cluster ready to be used for your own data exploration tasks. First, we need to introduce application descriptions. Zoe is completely independent from the services that compose a particular application. Zoe works with application descriptions that contain all the information needed to start containers with the processes the user needs. In our case, Jupyter, the Spark master, and a few Spark slaves. ZAPs are JSON documents that contain some metadata and the descriptions of each service that the user wants to run as part of the analytic application. Service descriptions tell Zoe how many copies to run, in which order to start them, and, since currently we are using Docker as a backend, some Docker-related information. Right now, services and ZAPs are created via a set of Python scripts, available in the repository shown on the screen. However, we are working on a new and completely redesigned web interface for Zoe that will also let users define their own ZAPs in a much simpler way. For this tutorial, we are going to use a Jupyter Spark ZAP. Keep in mind that if you want to use TensorFlow or Flink instead, a new ZAP can be created to accommodate that need. Our application is composed of 3 services. One Spark master, a few Spark workers. We need one to produce useful work, but if we have more, computations will be faster. And then we need one Jupyter notebook configured with a Python Spark kernel. For each service, a number of tunable values are exposed to adapt the ZAP to the user needs. Now I am going to open the Zoe web interface. I am going to log in, and since the browser already recorded my credentials, I am redirected immediately to the main page. Here there is a list of the ZAP executions currently defined, with their status and some more information. Links on the right of each execution let the user control the ZAP status to terminate or restart it. Since I logged in as an administrator, here I can see executions from all users. Using the link at the top of the page, we can create a new execution. Here we have to pass in just 2 parameters. A name to help us identify this execution, and the ZAP description as a file upload. As a name, I will write demo, and as application description, I will use one I already have on my PC. By clicking Start, we submit the request to Zoe that will queue it in the scheduler. Then we are automatically redirected to an execution detail page, where we can see the new execution. Here we have the same information as in the previous table, but also the status of each service, with links to its web interfaces, if any. Now the application is running, and all the links are now available. If I open the notebook interface, I can start working. Here, I can upload a notebook. In this case, I am going to use a notebook from the laboratory sessions in our algorithmic machine learning course at Eurecom. Here it is, and upload. Open. To show you that this notebook is actually connected to the Spark cluster we just created, I am going to execute some code. So run all below. And if I now go on the Spark web interface through the Zoe page here, I can open the master, for example, And here we can see that we have two workers, and all the resources we assign to them are being used. If I open the application web UI from Spark, we can see that the job is progressing, and it is actually the code from our notebook. Here we completed a work account, and here we have a work count. Here. This concludes this demo. I showed how to use Zoe to execute a ZEP, and how it is fast and easy to get from nothing to a fully working, top-of-the-line analytic framework, thanks to Zoe.